Let's do an example. Chelsea is planning to save for a trip that she will be taking in 6 months. Her plan is to deposit $400 at the end of each month into a short-term investment account that earns 7.19% compounded monthly. Let's go over the values for the variables. 6 months is the time, but this does not have the proper units since it is in months. So I'll change it to years, 6 out of 12 months in a year, so we get 0.5 years. 400 is the payment, since this is the amount we'll put into the account every month. 7.19% is the rate, and we'll write that as 0.0719, and compounded monthly means little n equals 12. Let's put all this information into the formula. We get FV equals 400 times the quantity 1 plus 0.0719 over 12 raised to the 0.5 times 12, all minus 1. And then in the denominator, we'll have 0.0719 divided by 12. If you put this in your calculator, you get $2,436.24. Part B asks, how much money will she have deposited? Well, let's figure this out. Each month, Chelsea puts $400 into an account, and she does this for 6 months. So 400 times 6 is $2,400. This is the total amount of money that she put into the account. Part C asks, how much money did she earn in interest? So there is $2,436.24 in the account. Of that, Chelsea put in $2,400, so I will subtract these two terms. So the interest is $36.24. Now, you may be thinking, well, what's $36? That's not that much money. The reason it's a small amount is because she's only invested it for 6 months. Now, suppose we expanded on this time for a whole year, couple years. You can see how the interest will increase very rapidly. Now we have part 2 of the problem. And in that, it says, how much money would Chelsea have to deposit today to accumulate the same amount of money as we found in the first part of the problem, if the rate and the time were the same? Okay, a couple things to note. This problem is saying how much money would she have to deposit today? And then it says to have the same amount of money as we found in the first part of the problem. Well, in the first part of the problem, we found that in 6 months, she has $2,436.24. What is being asked here is, what is the lump sum? Now, I have a table on the problem, and if you notice, on the left-hand side is the breakdown of the saving plan formula. And we see her first payment of $400. Then the next month, we earn interest on that $400, plus we make another deposit of $400. And then we do the same thing for the following month. We earn interest now on that $802, and then we make another $400 payment. Now, what this problem is saying is, I want to have $2,436.24 in 6 months. How much money should I put in today? So we're not making a payment. We want a lump sum value, which is going to be our present value. We will be using our compound interest formula. This formula does not have any payments. We are given the future value, and we know the rate, and we know the number of compoundings, and we know the time. The thing we do not know is the present value. That is what we're going to solve for. So we have our formula. Here is the future value, $2,436.24. We don't know the present value, the amount we're going to invest to start with, but we do have the rate and the number of compoundings in a year. And we have the length of time, which is 6 months or half a year, times the number of compoundings in a year. Okay, to solve this, I'm going to leave the left-hand side alone. And then present value, I don't know what that is. That's what I'm solving for. I want to first figure out what this number is. So put it in your calculator, and you should get a number like this. Now, don't round any intermediate calculations because then we lose precision. Now, I'm going to divide both sides by that number, and I am left with the present value equals $2,350.46. This is how much money I would put into an account today so that in 6 months I'll have the same amount of money as if I paid $400 into an annuity every month for 6 months. All right, now let's figure out the interest. The interest is just going to be all the money I didn't put in, the money I earned just from the money being in the account. This will be our final minus the amount that we put in. The amount of interest was $85.78. Now I will show you how to do this same calculation from part A using the app on your graphing calculator. Capital N, remember, is little n, number of compoundings, times the time. Well, the number of compoundings is 12, and then we're going to do it for half of a year, so this will be 6. The interest rate gets put in as a percentage, no need to change it to a decimal point. When we start out, we have $0. Then we're making a payment of $400. And then compounded monthly is little n. So PY and CY are little n, which is 12. Then the thing that we are solving for is future value. Now I will enter all these values into the app on the graphing calculator. On your graphing calculator, click on Apps, then Finance. That's the app that we want, and it's already highlighted, so I'm going to press Enter. Then I want this first option, the TVM Solver, so I'll hit Enter. Now in your calculator, you most likely have some information from an old problem. We could just overwrite the numbers from the previous problem. Capital N was 6, and then I hit enter to get to the next line. The interest rate was 7.19. My present value was 0. The payment is 400. FV is what I'm solving for. I'll just hit enter to skip that for a moment, and then PY and CY should be the same, and they're both little n, which is 12. Now go up to FV and click on Alpha, the green button, and then enter. As you'll see, I get the exact same answer that I got for part A when I did it by hand. And a quick reminder, just ignore the negative that is in front of the 2,436. That's just a programming thing. We just take the absolute value of that number.